Okay, 6.6, modeling with trig functions. We are using trig functions, so it could be a graph, could be an equation, to model a behavior in nature, in life, whatever the case may be. So I have two examples up here, one with words and one in a table, and I'll try to give you some pointers on how to approach both. So this is about tides, high tide and low tide. So on a day in October, the tides have a high point of approximately 10 meters at 2 p.m. They have a high point of 10 meters at 2 p.m. and a low point of 1.2 meters at 8:15 p.m. Right away, I have max and min. I have pretty much everything I need in this question as soon as I have the max and the min. There's another part of this question though. If a boat exiting the harbor at 6:30 needs a water depth of at least 2 meters to exit, will this be possible for this boat at that time? And you can see how that close that time is because I drew a little graph, 2 seconds. I just have 2 points. So I'm trying to kind of visualize what's happening. Here's the high tide. Here's the low tide. This is where 6:30 is happening. And this is, I just did a dotted line at 2 so I can visualize it. And you can see like, yeah, I'm going through it, but I don't know if my graph is accurate. I mean, I'm just a human, right? So I don't know if it's going to be 2 meters or not. So I have to create an equation. So to create an equation, if I have a max and the min, I have everything. I generally start with the y values, a and c. So if I want to find my a value, remember my a value is half the distance from the max and the min. Half the distance. So it's the max minus the min divided by 2. 10 minus 1.2 over 2. 8.8 over 2. So a is 4.4. A value done. Next, I'm going to do C value because it's so similar to A value, except it's just a different sign. The C value is max plus min divided by 2. The C value is the midpoint between the max and the min. So we use midpoint formula. So C is 10 plus 1.2 over 2. C is 11.2 over 2. So C is 5.6. So I got my A and my C value, the outside of the equations, done. Now I got to focus on the difficult stuff. Okay, now the phase shift is generally difficult, but it doesn't say which equation to use. Therefore, the phase shift is very easy because I'm going to use cos. Okay, wherever I see a maximum, it's given a maximum. I'm definitely going to use cos all day. So that eliminates a phase shift. Well, not really. I mean, the phase shift is 2. But let's talk about the period first. I don't really have one cycle on this graph or in this scenario, but if I have the max and the min, this represents half of the period. So I know that, I'm running out of colors, this distance from max to min is a half of the period. I'm running out of green. So I'm going to count the horizontal distance for that half period from 2 to 8:15. 2 to 8:15 is 6.25. Okay, I got to talk about that too, actually. 8:15 in math, that's English. 8:15 is 8.25 because 8:15 is 8 and 15 minutes out of 60. Okay, that's how we turn it into a decimal. If it's not 15, you know, what if it's 14? What if it's 7? Okay, so you could just turn it to a mixed number, and this 15 over 60 turns to a 0.25. Okay, so there's going to be other scenarios where it's not going to be as easy as a 0.25, where you can calculate it in your mind, turn it into a fraction. Okay, so if I know the half the period is 6.25, I know that the period is double that, 12.5. And if I know the period, I can now move it into K. K equals 2 pi over P. I don't like decimals, so I'm just going to double both to get it out of the decimals. It's 4 pi over 25. So I have pretty much everything. I can come up with my equation. Y equals, I'm using a cos function. I'm going to use my A value of 4.4. I'm going to use my K value of 4 pi over 25. My phase shift, talk about it in a sec. My C value is 5.6. Okay, and the D value is just going to be, well, if I'm using cos, because that's what it depends on. So after I figure out which equation I'm using, cos, I'm going to see, well, the maximum occurs 2 p.m. shifted to the right, therefore x minus 2. And I'm done. Okay, if I wanted to use a negative cos function, I could have started at 8.25 with a negative cos function, but that's further away. That doesn't make any sense. Okay. I don't really use a negative cos unless a cos is not visible. If the maximum for some reason is not visible and it's just quicker to process the negative cos, the minimum, I'm going to use that. Okay, so I have my full equation with everything that I need. Now it says, I got to figure out if the water depth is going to be sufficient at 630. So all I have to do is plug in 630 and see if the water depth, the y value, is going to be, is it 1.9? Is it 2.1? If it's 2.9, the boat can exit. Sorry, 2.1. So I just go here. Y equals 4.4 cos of 4 pi over 25 x, sorry, 6.5 minus 2 plus 5.6. Definitely need a calculator. Well, I don't know about definitely, but yes. 4.4 cos, open bracket, 4 pi over 25. Open another bracket. 6.5 minus 2, should have wrote 4.5, plus 5.6 equals, I'm missing a bracket. There we go. Y equals 2.79, but this definitely looks wrong. Hang on. Okay, so never mind, it's actually right. So at that time, the height of the water is actually 2.79. So therefore, the boat can safely exit the harbor. Okay, if you ever go to the East Coast, you can see kind of boats that are parked when the tide goes so low on the East Coast of Canada, the boats just like kind of tip over at night or whenever it's low tide. And then the tide comes back in and they go back up and then they start floating and then they can use them again. Okay, so no matter if you have a graph, no matter if you have a word problem, no matter if you have a table, set up your A value, your C value, and these are all found with the max and the min every single time. Okay, the biggest challenge is going to be if I can't use cos. That's not even that big of a challenge, just like one extra thinking step. So I'm going to try to not graph this because I want to show you how easy it is to visualize trig in a table. But if you get stuck, you can just graph this, because if you're looking at this, maybe it's easier for you to figure out the period and the max and the min, the C value, blah, blah, blah. But I'm going to go with this, and I'm going to find where my maximum is right here. And I'm going to find where my minimum is. It's kind of tied over here, but let's go here. Now, there's something missing in this question, and there's a lot of questions like this in this section that has seemingly missing information. This is talking about a table that shows the average daily temperatures for Hamilton, Ontario. Find an equation to model this data, then use your equation to model or to find it on 200th day. Kind of the same thing we did over here at the end. I got to plug in 200. But there's no information about the period, really. I could say this is the half period, just like I did in this previous question. Okay? I could do that, but it's just easier to understand that this is based on a year, and there's 365 days a year. So a lot of the times when if you pick sine versus cos, you're going to be off by the guy next to you, maybe by 1 or 2, because your model is a little bit different based on the data you use, based on the points you use. So to get rid of any error is great. 365 is the period, and you're done. Otherwise, I have to do 197 minus 15 is 182 times 2, 364. Oh, close. Probably not going to really impact your answer if you use a 364, but it's 365 and we know that. So I'm right away over here going to say, I know the period is 365. Some outside understanding. Okay, let's find my max and my min and my A value. So the A value is found with the Y values. So I need my max, 21.9, minus my minimum, which is negative 4.8 over 2. This is going to be plus, so that's 26.7. $13.35. Yeah. A value done. C value next. Max plus min, 21.9 plus negative 4.8 over 2. C is 21.1, 17.1 over 2. So C is 8.55. Okay. I love this milestone. I love finishing the Y values. It's kind of a little bit of a dopamine fix because I'm like, I reached that goal. Y values are done. So I can work with the period here. I'm going to find the K value. Remember, you need the K value. Okay, can't reduce that 365, that 2 over 365. I don't never want to change it to a decimal. I love things in terms of pi. So K value done. So I didn't graph this or anything. I just used knowledge of max and min. I even avoided the 167 minus the 15 because I just understood the period is 365 for a year. Okay. And I have one thing remaining. So I'm going to use, as always, cos. Cos starts here, negative cos starts here. Okay. Choose what you want. I'm going to say y equals cos. I'm going to plug in my A value, 13.35. I'm going to use my C value, plus 8.55. My K value goes here, 2 pi over 365. And my X is just here. I got to find the D value. If I'm using my max, which is a cos, I'm 197 to the right, minus 197. Okay, that's it. So that D value is that last piece of the puzzle where I'm like, as soon as I decide what I'm using, 197. Oh, you wanted to use the minimum, negative cos, 15 to the right. So what if I wanted to use a sine function? A lot of ways to think about this. I'll try to verbalize them. A sine function is right in the middle of the max and the min. So you can technically find the midpoint of 197 and 15 and see what value that is. But that information is generally hidden. For instance, it's going to be this 8.55, right? Sine starts at the C value. So there's no point to find the midpoint. It starts here. So you have to find that 8.55 somewhere in the table. It's probably in the middle of here. 8.55 lies between 6.6 and 12.7. So my sine function starts between here. And again, I could just estimate 116 is the midpoint between 106 and 136. No, it's not. Yeah, it's like 120, 120. Okay. Again, it's kind of just an estimate. I can use the ratio of how far away 8.55 is away from 6.6 to use that same distance from the 106. There's a lot of strategies I can use to be like max accurate. But to me, max accurate, use cos. If I wanted to change this into sine, what I'm doing is I'm taking a quarter of the period. I'm taking a quarter of the period and shifting it. That's the easiest thing to do because it's always accurate. I'm using accuracy, 197. I know the period's 365. If I take a quarter of the period and move this way, I'm going to land at the exact value that sine starts. Okay, so that's the best way to understand sine. It's just a quarter of the period away from cos. Just make sure it's in the right direction. If you ever forget which direction, actually in the table you can kind of see. Sine always starts where it's increasing. So if this is what you pick as sine, yeah, it's increasing this way. So that's positive sine. And if you see that it's decreasing, just slap a negative sign in the front and you're good. Okay, last step. Y equals 13.35 cos of 2 pi over 365. 200 minus 197 plus 8.55. I hope someone's doing this with me. 13.35 cos of 2 pi over 365, open bracket, 3 plus 8.55, and I get 21.9 or 21.88. So on the 200th day, and that 200th day is right after July, right after the max, the average temperature is around 21.9. But sir, it's like 21.9 on the 197th day. Yeah, I mean, it's 21.88, right? So it's already starting to fall from that 21.9. We just rounded it. You know what? I'm going to put 88 so we see that. Less confusing. Okay, so 3 days after the max, the temperature started to drop. Okay, and that's it for 6.6. Remember, these are your keys, A and C, your max and your min. Everything is solvable from max and min. No matter if you have a word problem that gives you a max, as soon as you get that max and the min, hallelujah, you're out of the question. Now just do the work. Okay, and if you can't do it from the table, just draw a cheap little graph. It'll help your brain.